So it's still not very much there, but there's a lot more there than there is here. I mentioned earlier, I think I was talking to somebody before the lecture, if you could convert all of the energy in a raisin, all the mass in a raisin, to energy, pure energy, you could light New York City for a day. Helium from the sun is in the cosmic rays, deflected from the Earth, but landing on the moon. In fission reaction, you break apart a heavy atom. The sum is not always equal, the sum of the parts is not always equal to the total. It turns out that when you break apart a heavy atom, some of the mass is converted into energy. So a uranium-235 atom, for example, has more mass than when you take apart all the different pieces of it. But you have to take them apart forcefully, okay? So you bombard them with neutrons, which is N. It becomes U-236 and eventually cesium-140 and strontium-90, and it releases energy. Strontium-90 is, if you look at the chart of the elements, it's just like calcium. Where does calcium go in the body? Bones, bones. So strontium-90 got into the milk. Kids drank the milk and caused cancer. Because strontium-90 is a byproduct of fission. So this is what happened to a lot of Japanese. It happened around Chernobyl when the Russian reactor failed. It's dangerous stuff, and it has to be controlled. On a fusion reactor, we can use two forms of hydrogen, but we still get alpha radiation and neutrons, neutrons being the real problem. But if we use helium-3, we get protons instead of neutrons, and a proton is a charged particle. It has an electrical charge. So if we put a magnetic field around it, the protons can't escape. The neutrons have no charge. They go everywhere, and right now they're coming right through this room. And occasionally a neutron will stop in an atom and cause that atom to become unstable, and in some cases cause cancer. But it weakens the material as well. So it's dangerous stuff. So they're working now to get a reactor that will do this. And if they can, then that helium on the moon becomes extremely, extremely valuable. Here's a picture of an academic paper that was done, just to show you I'm not making this up. So current fission reactors produce a lot more radioactive waste. Then we have to figure out how we're going to bury it, how we're going to protect against it. It's all kinds of problems. $40,000 an ounce for helium-3. That's the estimated value that it would have if we can get it back to Earth and if we can get a fusion reactor to work, which they're on the verge of doing. They think by 2020. You don't think so?
Now, Princeton Plasma Physics Lab, so it's always a moving target. So that's still they're still estimating 10 to 20 years away, which they've been estimating for decades now. The other thing I might just make clear is that currently 20% of the nation's power comes from fission, and we, just so everybody's clear, our current nuclear power fleet is a safe fleet. Nobody's died,
Right.
no evidence of cancer. The downwinders, after all the nuclear testing, the government did extensive downwinders assessments, and there really weren't many demonstrated effects, including the uptake of calcium. There have been some cases of iodine, which affects thyroid. So I don't want anybody to leave thinking that nuclear is dangerous or bad. It's well controlled.
But you still have to bury the waste.
And that's a political problem, not a technical problem.
Well, okay.
Because Yucca Mountain has been proven, and the NRC just gave it its thumbs up, that it could be used as a repository.
Yeah, if you're near there, I think it glows at night. Okay. Yeah, there are different opinions on that, okay? However, if we could get 220 pounds of helium-3, it would be enough to power Dallas or Detroit for a year, and it would be worth about $141 million. So there's an economic incentive. Now, we'd have to dig 3/4 of a square mile to a depth of about 9 feet to get 220 pounds of helium-3 off the moon. Tremendous mining operation.
I noticed that on your graphic, it said you had to heat the soil to 1,400 degrees Fahrenheit. So where would the power, the fuel, come to create that
Solar cells.
solar cell?
Or in fact, they have nuclear powered generators that they could send to the moon. But it would probably be solar. Now, there's also hydrogen on the moon in the form of water. There's ice at the polar ice caps. So they could use electrolysis to generate hydrogen to make fuel. Yeah. There's all kinds of plans that NASA has for that.
So helium-3 is a gas or is it a solid on the moon?
Well, it's a gas embedded in rock.
Okay.
Yeah.
If people go up there and mine a lot on the moon, what is it going to be to the stability? What's going to happen to the stability of the moon and the Earth as a consequence?
They really have to dig a lot to cause instability.
Okay.
Okay? I mean, after all, we do fracking here. What's that doing? Nothing, right?
We have more earthquakes.
Yeah. You can deal with that.
They don't have the gravity, so what can they use to dig? I mean, it's pretty far down that they're going 9 feet.
Well, they use earth movers. Moon movers? Yeah. I mean, you don't need gravity any stronger than what's on the moon to dig. Okay? Digging is not dependent on gravity. In fact, it's a lot easier to dig because you can lift more with a given piece of machinery than you can on Earth.
How about the dust from it? Wouldn't it go?
The dust is a real problem. And I'm glad you mentioned that because when the astronauts got back in the capsule after they landed on the moon, they had all this dust on them, and it went all throughout the cabin. They had to clean out the cabin. So it's a real problem. And because gravity is so much less, you get a lot more dust. Yeah. Yeah. Good point. Good point. Okay. The Chinese are very interested in lunar helium-3 and have already planned a mission around 2017 to go to the moon and start surveying for helium-3. The Russians are also planning missions, so they're in a race. NASA, on the other hand, wants to go to Mars, which has absolutely no economic value at all. Makes sense, right? So there's a lot more helium-3 on the moon, less radioactive waste, longer reactor life, and worth a lot of money. Okay, finally, let's just talk a little bit about a fun topic, baseball on the moon. A baseball that was hit with the same force on the moon as it receives on the Earth will travel almost 4 times further than it does on the Earth. Okay? So what, 400 feet to the outfield on a baseball diamond? Okay. So about 1,500 feet to the outfield on the moon. Well, okay, so you got a bigger field, right? You got a bigger field. However, the human eye can only discern a baseball at a distance of about 1,200 feet. So here you have a center fielder. First of all, he can't hear the sound of the bat hitting the ball. Second of all, he can't see the ball. So he doesn't know if it's been hit or not. And he won't know until it gets within at least 1,200 feet. So for the first 300 feet it travels, he ain't going to see it. So now you've got an outfielder who is constantly scanning the sky, thinking there might be a ball.
And what happens if the ball hits it in this negative gravity and stuff?
Well, the only good thing is it might not be going as fast as it would on Earth.
How many
Still could get
how
injured.
many baseball fans?
Oh yeah.
But if the bat did hit the ball, if the batter hit the ball, would it go straight as it would here, or would it kind of?
Well, it would go up a lot further. Okay.
It would just arc more, but it would be.
It would go so high. It would go so high. Listen to this. That a runner, a base runner, who can run as fast as he can on Earth, okay, might have time to run all the bases, go back to the dugout, sit, and wait and see if he scored. Reminds me of the old story in World War II about the pilot that shot himself down. Did you ever hear that story? Well, it was a plane that could go very fast in a dive. So while he was ascending, he fired bullets. Then he dove very fast, and his bullets came down on top of him. He shot himself down. Same thing here. So there's a reference. If baseball expands to the moon, be sure to back up those fences.
Presumably the ball would go faster too because there's no air resistance.
Yeah, there's very little, yeah. True. Here's possible solutions. You could use much heavier balls and much lighter bats, right? At the risk of breaking the bat when it hit the ball. And you could play in pressurized domes to provide the air resistance and the sound. But if a meteor hit that dome, then you'd have a little problem. And meteors are more likely to hit the surface of the moon, right? Because it has no atmosphere to burn them up. That's why there's so many craters on the moon, as opposed to the Earth. You could play football with a lighter ball. You could give up baseball for chess, or you could just stay on Earth. Ladies and gentlemen, it's 2:30. So to summarize, the moon has some oddities associated with it. You'd weigh a lot less. The sky is going to be black, not blue, because there's no atmosphere to scatter the light. There's no sound, except you could use radio transceivers. Buildings could be very high and made from lighter and stronger materials, like titanium. Physiological effects would abound. China and Russia are racing to get that helium-3, and you'd have to change the baseball rules and the field measurements. Serious political problems. Thank you very much.
Thank you.
I have a half hour for questions. Any questions? Yes, ma'am.
So do you suppose the Chinese and the Russians are going to share their helium-3 with us?
Do I really have to answer that?
For a price.
For a price, right. Yes.
Do we have volcanoes on the moon?
Pardon?
Volcanoes.
There is some indication that at one time there was volcanic activity, but not anymore.
It's not active.
No.
I missed when you said that the sun exerts more force on, is it the moon or the earth?
The sun exerts more force on the moon than the earth does.
Oh, okay.
On the moon than the earth does. About 175 times more force on the moon.
Since there's no sound on the moon, what happened to one small step for man, one giant leap for mankind, when they said that?
Radio. They were using radio.
Would they have been able to hear each other?
Through radio transceivers. Yeah. Yeah. Yes, sir.
So there really is, I mean, other than, there's really no minerals or no real economic advantage to going to the moon and mining the moon, or other than this helium-3. Is that right?
That's my take on it, and that agrees with most astronomers. Yeah. So we're not even planning to go. China and Russia will probably get there before we do if we ever go back. We're going to Mars. And what's on Mars? Nothing.
That's why I asked before in terms of getting on the moon, the Americans getting on the moon, from a military or strategic standpoint. I mean, what would be the advantage of using resources to get men to the people to the moon, other than strategically or militaristically? I don't, like you point out, there are other ways that we're using satellites to do what we could otherwise do by being on the moon.
That's why we're not.
Yes.
Do we have those faults on the moon, or earthquake, a lot of earthquake in the moon?
There are faults.
Faults?
Yeah, but we don't think there's very many earthquakes anymore. It's a more problem of impact from meteorites and comets. Yeah. Thank you again.
Thank you.
Okay.